Hello and welcome to today's episode of Rawkode Live. I'm your host Rawkode. Today we're going to be taking a look hands-on introduction to C++. Now before we do that, there's just a little bit of housekeeping. First, if you're not subscribed to the YouTube channel, I would encourage you to do so now. Subscribe and click the bell and you will get alerts for all future episodes of Rawkode Live as we explore and learn this vast cloud-native landscape together. If you're not watching live and want to come join us in the chat, there is a Discord server available at rawkode.chat. Come in there, say hello. We talk about all things cloud native, Kubernetes, rock music, and a whole bunch of other things in between. So we look forward to welcoming you. Now, to guide us on our journey into C++ today, I am joined by a C++ developer advocate at Microsoft, Cy Brand. Hi, Cy. How are you?
Hey, good. Thanks very much for having me. How are you doing?
Very well, thank you. And it's a pleasure to have you here. I've seen a few of your
Yeah.
talks over the last year, all very, very interesting, exciting, and very low level at times. But I think those primitives are a really good way to try to understand really complex topics as well. So I'm very, very excited to have you here today. Can you do us a favor, and just for anyone who is not familiar, hasn't seen our talks, doesn't follow you on Twitter, give us the introduction to Cy.
Yeah. So my name is Cy Brand. I work as Microsoft C++ developer advocate. I spend most of my time on Twitter, just like making nonsense. My background is in compilers and debuggers, toolchains for graphics cards. I spent about 5 years writing like GPU compilers and debuggers, which is where I got like fascinated by really low level stuff. And yeah, that's where my kind of love for developer tools and things like that came from. So then I've been at Microsoft for a couple of years now, and still like giving talks about C++, getting involved in the ISO standardization. Like I just got a feature, hopefully getting into C++ 23, which just got approved a couple of days ago. So I'm very excited about that.
Awesome. Okay, well, we got people saying hello in the chat. Hello, everyone, and welcome to today's session.
Everyone.
You also like to explain low-level concepts with your cats, and you have your own YouTube channel. I will include a link to that in the description, but you want to tell us a little bit more about that if you want?
Yeah, sure. That was basically I come from like a very traditional background of computing. Like I did a CS degree. I have been programming for since I was like 10 or something. So I like come from like the traditional background. But then when I went into industry and started working with people who come from different backgrounds and saw how they saw things and explained things differently, and it was sometimes a lot more digestible, a lot more understandable the way that they were approaching things. I wanted to try and like join those two things together, like bring all of the knowledge and interest I had from like low level concepts, from my experience with compilers and from my degree and things like that, and take different approaches to trying to explain these, like explaining them with household objects and my cats and whatever I happen to have around. So
Yeah,
that's
the odd
that's kind of where
child
that
toy,
came
I think,
from.
has popped up now and again as well.
Yeah. I explain hash tables with my kid and some teddies, and the hash function is how cute the teddies are,
Awesome.
which is a terrible hash function, but
It makes it fun and entertaining while learning these concepts. So, I think you're due a lot of
exactly.
credit for producing this content and material. It's a joy to watch. Okay, now you've got your biggest challenge of all, which is to introduce me to C++, a language that I haven't played with in many, many years. But I'm going to give a shout out to one of my former colleagues, Stuart, who works at Influx Data, who kept telling me for years now, go and look back at C++ because it's not the C++ that I'll remember. Like, he had many good things to say about the evolution of the language. I think you just mentioned that version C++ 23 is now a thing. So
23.
like, I'm curious and excited to see some of these new constructs in the language and how they're going to hopefully improve it to me. I think my image of C++ back, and let me clarify, this has gone back at least 15 years, I think. So to me, it was a difficult language. Having only ever done Perl and C at the time, I think now, hopefully with my experience, it's going to be a lot more familiar and easier. But he's always had said really good things about modern versions of it. So I'm excited to learn that today. Okay, let's jump over to my screen share. We're using Exercism today. Are you familiar with Exercism at all?
No, I had like a brief look, but yeah, I've never used it before.
Yeah, it's a really cool project that has like language tracks. In fact, let me just quickly do the 30-second pitch, but it
It
has
seemed like it
language
had a
tracks.
lot of tracks.
Yeah,
It's
it
like,
says here showing 50, and I'm assuming there's maybe,
jeez.
yeah,
I love that it has a
x86.
x64 assembly one. I kind of want to do that one. I haven't done that much x64 in a while. That would be cool.
Yeah, it's a nice website for picking up a new language. It kind of guides you through a bunch of different problems. That start with like really easy things like Hello World, simple challenges which normally involve working out leap years, etc. But then they go down to more difficult things, and that kind of guide through the language would be cool enough on its own. But you'll see here it also says there's mentors, and all that means is that when you submit your solutions to problems, is that the mentors generally review them and give you feedback on how you can write more idiomatic code in that language. So it's a
Right.
really
Yeah.
interactive way of learning as well.
Yeah, I think that's really like valuable thing as well because there's getting the right answer and then there's having a solution which is like actually idiomatic and maintainable and performant, and those can look very different. So yeah,
Oh,
having
yeah.
that mentorship on top sounds like a really good thing.
Awesome. Well, I think we should start with Hello World. I think it would be rude not to.
Sounds good.
I have a local directory here where I've already downloaded the Hello World example. I have my VS Code open, and I've got the basic files here that we need to get started. So let's open the README. Probably a good place to start. So our objectives here, and I like that it always kind of lays out what we want to do. The other nice thing about Exercism, for people that aren't familiar with it, is they provide tests for all of the examples. So your goal is actually to make the test pass, which means you get introduced to testing in the language as well as writing code, which I think is really important. If we pop open our test, I have never seen a test in C++ before, so this is exciting.
Okay, so this is using the Catch2 testing framework, which is probably the most popular testing framework for open source projects right now. I would say it was developed by Phil Nash, and it lets you have these like quite nice requires statements where you just say I require that hello world hello is equal to hello world, rather than like some other testing frameworks where you'd have to say like require equals or require true or things like that.
Okay, so this makes sense to you then as a test case. Good.
Yeah.
Good. That's good. And is this the test framework you would use as well? And your
This is what I use for my open source projects as well. Yeah. So that test case in Shouty case is this is a test case and it's called test hello. In fact, one of the cool things about Catch is that you don't need to use like C++ identifiers for your test case name. So you could call that test hello as 2 words if you wanted. You could use special characters in there. You can do whatever you want. And then you can also, it also takes a tag. So you can like split up your tests into different tags and like run large subsets of tests. So you want to like run only the like command line driver test, or you want to only test like some part of your application, that you can do that with Catch. So it's quite nice.
Okay. Well, I mean, there's one thing that's jumping out to me right now that is confusing me. Is that at first I thought these were function calls, but I noticed that the test case here has then got braces after it, which makes me think it's maybe not a function call.
Right, exactly. So these are macros. Macros in C++ is essentially the same as C macros if you're familiar with them. So they're the idiom is to use all caps when you have a macro, because macros can do weird things which normal like C++ functions cannot do. So bringing attention to the fact that, hey, this is a macro, pay attention, something weird might be going on, is why we use shouty case. It's like how Rust uses the exclamation mark or the bang after the macro name, just to draw attention to like, hey, there may be dragons here.
Yes. Okay, that makes a lot of sense then. So these are macros making writing tests easier. But
yeah, exactly.
I've got one more question. This is not really related to the test case here, but is there now like a de facto way in C++ to pull in libraries? Like, is this pulling in a catch library through a package manager or something, or?
That's a very good question. So basically, we are um, so C++ was originally standardized in 1998, like a very, very, very long time ago, when like dependency management uh, was not a thing which all languages just had, and they had great solutions for handling your dependencies and saying what your dependencies were and what versions they were and things like that. But C++ is having to evolve, so there is no standard dependency management tool, nor de facto or de jure. There are a few solutions. The two major ones are Conan and VC Package. VC Package is the Microsoft one, so it's the one that I'm most familiar with.
Okay.
Um, so this, I can't tell what this is using just by. Okay, it looks like it's literally just
Pulling
using
in the
the
files.
header only version of cat. So yeah, when you cloned this directory, it just has a copy of the cat testing framework in it. So it's not using any dependency management stuff.
Okay. Well, that's good to know. That makes a lot of sense. So I'm keen now that we jump into our hello world. Like, we got the test. I understand this. Require is like an assertion in C++, or at least in the catch framework.
Yeah,
We're
exactly.
calling our hello function, and we're expecting to get the string hello world back.
Yep.
If we look at our code, okay, this looks a little bit different from what I remember. So the good thing is I remember to include pragma. I
Yep.
do not remember namespaces or using keywords.
Cool. Well, I can walk through, I guess, from top to bottom. Kind of makes sense. So
Please,
the
yeah.
very first thing at the top there, that hash include hello world. This is how you bring other functions or names or types from other files into your current file, essentially. So C++, just like C, has things split up into implementation files, like this one, which is a .cpp file, and header files, which are .h or sometimes .hpp as well. Different people use different things. But basically, the header files are a description of the types and functions which you can call and use. And then the implementation files are the actual implementation of those things, what the actual code does rather than how you can use it. So this hash include just brings everything in that hello world.h to make it available in this file. And it literally does do textual inclusion. So when you do a hash include, it like literally takes the entire contents of that header file and dumps them into this file. There are in C++20, which is the most recent version of C++, has a feature called modules, which is a more, like, if you're familiar with modules from other languages, it'll be a little bit more more reasonable. It doesn't just dump in entire text files. It like actually looks at the symbols and names available and exports them in sensible manners. But this is using the old style, and I think the version of Clang you're using, which is the compiler, doesn't support modules yet, so we can't use modules. But anyway, modules will make this better. Anyway, and then the using namespace std. So std or std is the namespace where everything in the standard library lives. So std string is the standard library string implementation. So when you say using namespace std, that says, okay, if I type some unqualified name, just like we do later on, where we say string and we don't say std string, we don't say some other namespace string. If I just say string, then I want you to look in the std namespace. It's basically a way of stopping you having to type the namespace. I will say that it's probably not that idiomatic to using namespace std. Some people do it, but generally I like to make it obvious when I'm using something from the standard library,
Sorry, are you
as
saying
opposed to
it's
my own code.
idiomatic to maybe just do this and not pull in instead?
Yeah, that's what I would prefer to do, but it's you can do either. The main thing is to not write like using namespace std in a header file, because then that will get copied into everyone else's files, and now you're like looking for standard library names when you maybe didn't want to.
In fact, I just noticed this comment here, which is actually telling us that we
Right,
could
absolutely, yeah,
do that as well. Okay.
So then when we say names on line 5 now, when we say namespace hello world, this is defining our own namespace. So everything in the standard library lives in the std namespace. Now we're saying, okay, everything inside these braces is inside the hello world namespace. So this is just a way of like qualifying names so that, if I have a function called hello and I include some other library which has a hello function, that they don't conflict with each other.
Is that mandatory?
Nope. So you could just completely get rid of namespace hello world and the closing brace at the end, and you would just have an unqualified hello function which lives in the global namespace. Right. So you can do that, but you shouldn't, because then if someone else does that, then everything goes horribly wrong.
Plus, our test does seem to fully qualify it here. So
yeah,
I guess.
And the test could, just like we had earlier, the test could say using namespace hello world, and that would be a very, very reasonable thing to do in your test suite. If you're going to be using all the names from your own library anyway, then you could just write a using declaration like that.
Okay, awesome. That's great context. I'm going to make a wild assumption right now that just changing this to hello world is probably going to pass my test. So Can we walk through the process then of confirming that? And then we do have a couple of questions in the chat that I'll get to in just a minute, Daniel and Kai. So
sure.
I've modified this. I think my test is good. I'm assuming I jump to the command line, go into the directory. I'm presented with a CMake list.txt, which I'm not entirely sure what that is. I'm sure I could read the README, but do you want to just give us the TLDR on building this thing?
Sure. So just like with dependency management, there is no standard build system for C++. However, CMake is essentially the de facto build system nowadays. It's what most C++ projects use for building. So it's essentially its own language. So if you like look at the CMake lists.txt, that's a description of how to build your project, and it's written in the CMake language. So we have things like this add executable command that is saying how to build the executable for our project. And you can see further down where it says set target properties, that's saying, oh, we want to use C++ 14 as our version of the standard, and we don't want any extensions, like if we have compiler extensions from Clang or GCC or whatever compiler you're using. So
is CXX a way to? Does that always mean C++ rather than CPP?
Yes, right. CXX is the way that is the term that CMake uses, which is what like AutoTools used as well. If you ever used AutoTools back in the dark ages.
It's quite a lot to build Hello World.
Yeah, this is not like all necessary. Like if you wanted to have an absolutely minimal thing, all it would literally need is a minimum CMake version and project specifier and an add executable. Like this whole thing could be 3 lines if they wanted it to be, but they're probably doing other things. Like they've got stuff to run the tests later on and whatnot. So
yeah, I guess this is just one of those things that as you start to work with more C++ and get more acquainted with the tooling and stuff, it all becomes a lot more familiar, I guess, like any other language. Okay.
So if we want to build this, then the usual thing you would do is you'd make a directory called build, and then change there into there, and then run CMake space ... Yeah. So CMake is not actually a build system. CMake is a meta build system, which sounds kind of weird, but basically it's because there's so many different ways to build code in in Windows or in Linux or Mac or BSD or whatever you're using. CMake generates a build system for you. So if you use like Visual Studio, then CMake could generate a Visual Studio solution. Here you can see it's generated a make file. Nowadays, a lot of people use Ninja, which is another build system. So yeah, this is the make file which is generated for you. So now if you run make, then it will build your project.
I know make. That's something.
Yeah.
All right. So
you can also run CMake --build which will do your build step regardless of what generator you're targeting. Oh, we had a capital letter mismatch.
I broke my code already. All right. So we can change that back.
Oh, we're changing the test instead of the code.
Oh, did I? Oh.
Yeah.
Is that not? No, of course not. Right. Okay.
That's what I do if my code doesn't work. I just change the test until it passes.
There we go.
Yay.
A tested
Okay.
hello world and an introduction.
That did run the test as well. Yeah, because the CMake list had a target which ran the test for you. So nice.
Yeah, so our default target here runs all.
Yeah, generally you don't want to look at the make file that CMake list generated, but you can if you want. It's just it's not pretty.
Oh no, let's not do that. I'm more interested in the language itself, and we'll touch on bits of the tooling as needed. But so far, so good. It's all starting to come together. It's building a good picture in my head. Hopefully, also for the audience too. So
that's how you use CMake list from the command line. Also, Visual Studio Code has a CMake extension as well, which makes it that you can just build from within Visual Studio Code.
Oh, cool. Yeah, I don't need to find that right now. Let me read out these questions for you. I'll let you tackle them in whatever order you want, and then I'll get the next exercise ready. So Kai starts off with hopefully a nice simple one, but Kai is curious of how do namespaces differ from classes?
Yeah,
sorry, you go for that, and then we'll come back to
I can go for this one. Yeah. So a namespace is just a way to split functions and classes into digestible units in a way which the names do not conflict with each other. You cannot have like an object which represents a namespace. Like you can't create an instance of our hello world namespace. You cannot pass them around or do anything like that. It's just essentially a prefix to any names which are inside those blocks. So whereas classes, you can create an instance of one, you can pass one around, you can give it data members, you can give it functions which you can call on instances of that class. Namespaces are just name prefixes, essentially.
I guess if we were to correlate that to Go, which I think Kai has a bit of familiarity with, then namespaces would be like packages and classes would be like structs, which also happen to have methods on them as well, I think.
Sure. I don't really know Go, but that sounds reasonable.
All right. Now, Daniel seems to be jumping straight into the deep end, I'm afraid, with his first question. But he's saying a lot of folks in the cloud native community are used to Go, which, unless you're using GCC Go, pretty much has one compiler. Can you maybe talk about some of the trade-offs of the various C++ compilers?
Absolutely. So the main compilers which are available for C++ are Clang, which is the compiler which OS X uses, and is also available on Linux and now Windows. GCC, which is the GNU C++ compiler, so is the one which is kind of the default on most Linux systems. MSVC, which is the Microsoft C++ compiler, that's the team that I'm on at Microsoft. And there's also ICC, which is the Intel C++ compiler, but it's not quite as common. So as far as trade-offs and differences between them go, they're all good at different things. and which you target is sometimes related to which platforms you will be targeting. Windows, Linux. Quite a lot of projects will target multiple compilers. So like if you're building for Windows and Linux, then maybe you're going to target MSVC for Windows and target GCC or Clang for Linux. If you're writing a generic library, then you probably want to make sure that your code will compile on all of those platforms. If you are targeting just one specific compiler, then you can do like more aggressive optimizations. Or even if you're targeting multiple compilers, you can write code which will do certain things on with some compilers and use certain things on other ones. So there's a lot of different things you can do.
All right, awesome. I didn't realize there were so many compilers.
Yeah.
Okay, hopefully that answers your question, Dan. Now, we have cloned our second Exercism tutorial challenge. I'm not sure what we call them. But it wants us to determine if a word or a phrase is an isogram. An isogram is a word or a phrase without any repeating letter. However, spaces and hyphens are allowed to appear multiple times. I did not know what an isogram was until 3 seconds ago. So there we go.
Yeah. So is it adjacent characters or is it just okay? No, it's
yeah. I think
just
it's
if the character appears twice anywhere in the string, then it's not an isogram. Okay.
Oh yes. Okay. So yeah, isograms is not an isogram because the S is in it twice. Okay. So yeah, we can't have any letter twice in our word or phrase.
Yep.
So we already have, I'm just going to start with the test cases here. We've got empty string, that makes sense to start with. And we're expecting to get a true value back because spaces don't count. I find it curious that they actually define unexpected as a Boolean, and I'm not sure why it's got braces around it, and then have the assertion. Is that idiomatic?
No. I am kind of confused why they did this as well. So, and as far as that line 12 goes, that so maybe we can talk a little bit about variable declarations in general.
Yeah.
So the variable declarations here on line 10 and 12, they both begin with const bool. So bool is the Boolean type. Const says that this is an immutable variable. So changing this will not compile. If you do some shenanigans in order to get the compiler to accept you changing it, then it's undefined behavior and your program may blow up. So right at the start, we have the type of the variable. Then we have the name of the variable, which is actual in case of line 10. Then we have the equal sign and an initializer. So actual will be initialized to the value of returned by the function isogram is isogram. Now on line 12, this uses slightly different syntax for declaring a variable. So this is valid. It's not really idiomatic. Like I would just use equals true there if I was going to be either having require true equals actual or just having expected equals true. Yeah, exactly. I see very, very little reason to use braced initialization there. Braced initialization you mostly use if you're initializing like a container, like an array or a vector, and you want to give it a set of initial values. Like you want an array of 0, 1, 2, 3, then you would use braces and write 0, 1, 2, 3 in those braces. There's no real reason to use it in this case, I don't think.
Okay, well, I'm just going to remove that one because I don't understand it. In fact, I don't even
Sounds
really
good to
need
me.
this one. Like that to me seems perfectly acceptable.
Mm-hmm.
Okay, so let's see what code they've given us to work with. Nada.
Not a lot.
All right, so it's expecting an is_isogram function which takes a string. We have a namespace already, so I'm assuming. Oh, maybe I should disable Copilot. is that cheating?
All right, so we're going to be returning a Boolean, right? Because we're Okay, so now we can maybe talk about strings a little bit as well. So there's a few different string types in C++. If you go back to the test,
Yep.
so anything enclosed in double quotes like that is a string literal. So that's any string which is like embedded into your program. The type of a string literal is a constant character array. So this string literal will be a constant array of one character because they're null terminated. There's always a null character at the end. But string literals are, well, arrays in C-style arrays in C++ are a little bit weird because they can change to pointers. We generally try to shy away from them. So in C++, the main types we use for strings are std string, which is a string which owns its own data. It has a buffer stored inside. It can be modified. It can grow. And the other type is std string view, which is actually, if this is using std string view is a C++ 17 thing, so it might not even allow us to use string view. But string view is essentially a view into some existing string. So we don't own the memory. We're pointing at some memory which is stored elsewhere, and that could be a string literal, or it could be like an existing std string stored somewhere else that we're just referencing into. If you're familiar with Rust, then it's like a std string is the capital S string, and string view is like a ref stir.
Okay, yeah, that does make sense. The Rust string stuff I understand. I didn't know it was so similar to the C++ one, so that works really well. Now,
Yeah.
Is it string view? Is that what you were saying there? Like so?
Yeah.
Okay.
So that is what would ideally be used here. I think. I mean, we can try it, and if it doesn't compile, yeah, it's already saying this, but we'd have to include the header for it. So yeah, up there we do hash include, and then so there's two different syntaxes for hash include. There's hash include, yes, exactly, that's what we want. There's hash include double quotes, which looks for things in our own project, and there's hash include angle brackets, which looks for system include headers. So we would hash include string underscore view, just the same as std string view, but without the std. Yeah, exactly.
Oh, it's happy.
Okay, it's happy. We'll see if it builds. Okay, so what we want to do is isogram.
Yeah, so our first test case is just empty string. So I'm assuming if we have an empty string, we're just going to return true.
Yeah. So we could say if stir.empty.
Oh, empty. Okay.
Yep. Exactly.
Like so? Would that work?
Yep. All good. Mm-hmm.
And I guess we need a default case.
It's good to me.
I don't see any red squiggles, so that usually keeps me happy at the start. All right. So I would make a build directory. I would run CMake ...
Mm-hmm.
and then go.
Yep.
Okay, so I got something wrong. No member is isogram in namespace. Isogram.
Did we go into the header file? So yeah, we've got isogram.cpp. We also got isogram.h. So we need to declare our function here. So
would you just copy and paste this line?
Yes, and end it with a semicolon. So this is saying that somewhere nebulously there exists a function called isogram : is isogram, and this is the header file which people will include into their program in order to know that there's something we can call this. And then when we compile the program, then the linker is going to like work out where this function is actually defined.
So is it fair to make this, like any function defined inside of a namespace is essentially private until we add it to the header file, and then we're making it publicly available at that point in time? All right, okay.
Yes, you can think of it that way. It gets a little bit. There's more details, but yeah, that's a mental model which checks out for
Okay.
the basic cases. Yeah.
So if we run make now, then I'm getting undeclared. Oh, so I didn't use.
Okay, so in the header file, you need to also include string view.
All right. Okay.
Yeah, because the header file needs to know because it's taking a string view as a parameter. It needs to know like what the size of that is and how to pass one around and things like
Well,
that.
because this includes .h, do we still need the string view here?
No, you could get rid of that.
Okay. All right. Oh, it's compiling a bit longer this time. That's probably good.
Okay.
It still passed. Okay. Awesome.
Nice.
Let's see what our next test case is. Now, it looks like it's using, is this macros? Would you call them pragmas? I'm not sure.
Macros, yeah.
Macros. I'm assuming I could just remove that and that would bring in this test case, or
Yeah, I think there's probably something defined in the CMake which defines that, but yeah, you can just get rid of it as well, I'd say.
I'll just move
And
it
then
down. I'm assuming that brings in one test. I don't know why it's still grayed out. Oh, there we go. Okay. So now it really likes that brace syntax, I've got to say.
Yeah.
Now we want to call isogram on isogram. Okay, so now we're going to actually have to do our first bit of actual code. So I think we're going to need to be able to loop over each of our characters and just store them in an array. So maybe we could talk about first, how do we define an array to store scene characters?
Sure. So how are we going to be doing this? Are we going to be only assuming that our string is ASCII and then counting if there's more than one
yeah, I think
letter of each, or are we going to use a hash map, or there's a few different ways we could do it.
Yeah, so let's do a hash map, and then if the key exists, we'll just immediately return false. Otherwise, we'll continue to loop over and store them. And yes, we'll stick to ASCII. There's already been a joke about UTF-8 based on another series I do called Clustered. I'll talk about that later. No UTF-8. So,
okay.
Yes.
The UTF-8 story for C++ is a mess.
Yeah, let's stick to ASCII then. So first of all, like, how do I define a hash map then to be able to store the scene characters?
Yeah, so the default hash map in C++ for reasons is called std unordered _ map.
Like so?
Yeah, that's it. So unordered map is we'd have to include the header for unordered map as well, which is just called unordered map.
Okay, so we want to do it and include on or yep, there we go. Exactly. I feel like these ones should be above the string ones. Is that something you would do?
Sure.
Or? Yeah. Okay. That sure was like a whatever. It doesn't matter. But.
Yeah. So unordered map is a class template. So templates in C++ are the basic way to do generics. So if you're familiar with like traits from Rust or like Swift protocols or Java generics or whatever anyone else calls them, it's kind of a similar thing. So you can't just create an unordered map. You have to create an unordered map with some key type and some value type. So in this case, our unordered map is going to be a map from characters, which are char, char, to I guess just if we're doing a char to bool, like if we're just checking if we've seen it before, then we actually don't need an unordered map. We could do it with an unordered set. Because that's just checking whether it exists yet or not. Yeah, exactly the same. So we would just have an unordered set of
the
chars.
Template syntax?
Yeah, that's the template syntax. So, so for our declaration, we would need to say std unordered set will be the first thing in our declaration because that's the type. So we'd say std unordered set char scene. semicolon. Yep. And that will construct an empty unordered set, and that will be our scene object.
Okay, cool.
Okay.
So the first thing popping into my head now is when we call .empty, which I didn't know was possible on the string view, I'm assuming we can get the characters or an iterator or something we can loop over as well through a function.
Yep. So we could do that by calling functions, but C++ has the idea of a range, which is basically the beginning of some range and the end of a range, and those two things are called iterators. So anything which supplies a begin and end function is a range in C++, and we can loop over things which are ranges a lot easier than anything else. So we can use what's called a range-based for loop, which is like a for each loop or for in or whatever you might know from other languages. And so the syntax for that is just for and then parentheses. And then we need to say what the type of the thing we are looping over is. In this case, it will be characters. So just char. We need to give it a name. So I guess just C. Yeah, letter. And then colon. And then what we're looping over, which is stir. Yeah. So this reads for character C in string do whatever is within these braces.
Okay, so I'm assuming we can do scene contains.
Dot contains, I believe, is I don't remember what the interface for unordered.
We have find. Maybe we should just find.
So find will return an iterator. There is contains, but it's that's in C++ 20. We can use .count. So if you yeah.
Would that not return the size?
Yes, but .count will.
Oh, current. Sorry. No,
it's .count. So we'd see scene.count and give it C as the argument. Yeah, got 2 dots in there.
Yep.
Yeah, so this will, because it's an unordered set, then count is going to either return 0 or it's going to return 1. So
right, okay, gotcha.
If in C++, yeah, that will be fine. Yeah, so that will check to ensure that C is not in scene.
I'm just going to make this up now, but I'm assuming we could do this. I think this is going to do an early return, although I could be wrong. And I'm assuming here, could we continue?
Yeah, so you could do that. I generally try to not use continue in loops because it makes them very difficult to read. I would instead use put an else clause after the if and do a return false in there. Yeah.
Okay, well, it looks like it's complaining about my for loop. Let's fix that first then. Did I get something?
Yeah. Looks fine. Maybe try and compile it, see what the compiler says. Okay, that compiled just the test.
I think, okay, just my VS Code then.
Yeah.
Okay, so we are ranging over our string and pulling out each character. If the count for that character is 0, we're going to insert it. If it's not 0, that means we've seen it before. It is no longer an isogram, and we return false, which now means if we get down to here, we're actually
then we return true.
An isogram. Look at that. There we go.
Nice. Then we can, I guess, uncomment the other test, because there was another one.
looks like we may have a bunch, but
Yeah. I think just get rid of that if I think, and there'll be a matching one right at the end. There's a lot of tests. Yeah, get rid
let's
of that.
just
And
see.
let's just see if they all pass.
All right, we
4
got.
failed. All right.
Now we don't handle. There were some exceptions here, so it said hyphens and spaces are allowed. So I guess if we just quickly add a condition to not loop, to skip over them.
Yep.
So if C equals this.
So character. So things enclosed in double quotes are string literals. Things enclosed in single quotes are characters. Yep. So we want that. Yep. So we could say if C equals hyphen or C equals space, you could do it in the same. I was just saying in the same thing you had.
Oh yeah, we don't want to insert this, do we? Okay.
No, yeah, just have another. Yeah, perfect. Yeah, and then you've got a trailing.
Yep.
Yeah, so in C++, double bar means or. You can also just write or. That works as well.
Nice.
I quite like it. A lot of people don't because
I think it
they're
reads
more
well.
used to the double bar. I think it does as well. Yeah.
Okay. Should I continue in here or should I just do nothing?
Yeah, you can write a continue in there.
Because we've got the chained conditional, so we should be okay just doing that, I think.
Yeah.
Maybe. We'll see. The test will tell us. Oh, okay, so 2 edge cases. It's not really giving me... Oh, mixed case. So we have to lowercase it. And the last one is also just a mixed case thing. So...
Yeah, so we could use stood to lower or stood to upper just to normalize.
Can we do that as part of the range, or would you create a new variable?
Yeah, you probably want to. You could just do C equals stood to lower C. That's all one word, stood to lower. It's a can't remember which header it's in. Stood to lower is in the C type header.
Okay, and how would you work that out?
CC type.
Sorry, say that again, please.
It's CC type, 2 C's at the start. Yeah, that's an old C thing. Yeah, you would generally work that out just by going to CPP reference, which is I'd say the best online C++ reference website, and just typing in the function you want, and it will tell you what header it's. Yeah, exactly. That's it.
Okay. Oh, I forgot my semicolon formatted, which is usually an indicator that my code is maybe all right. And all of our tests.
Yay!
Awesome. Okay, there's quite a lot to kind of unpack here. So I like the unordered set. You said we also had maps. So there's all of these built-in data structures for handling, I guess, most of the common use cases. We got the range for, which was cool. Like, does C++ have functional primitives for doing this? Like, you know, the ability to maybe map, filter, etc.
Right. So prior to C++ 20, there are these things called algorithms, which are in the algorithms header. And those are kind of what you're looking for. We have things like transform, which is basically a map, let you run some function over all of the elements in some range. We've got like remove if. We've got like a couple, 2 or 3 dozen algorithms in that header. Yeah. The problem with those is that they don't compose very nicely. You have to essentially have like intermediate data structures. So like if you wanted to do a transform followed by something else, then you would like transform your string into some other string and then operate on that. C++20 has ranges which compose. So you could like build up a pipeline of operations and say like, okay, we've got my string, I want to transform it, then I want to filter it, then I want to drop the first three, then I want to do this, then I want to do that. And those would all they would happen lazily. So only when you ask for an element do all of those operations actually occur. But the version of the compiler you're using does not implement those yet.
Okay, awesome. All right, I'll throw one more question out because it's just something I've been curious about. Like my very old knowledge of working with C and C++ required a lot of mallocs and deallocations. We haven't had to do any memory management yet. Now, is that just because our types are mostly primitives or just because C++ handles some of this for me?
So basically, if you're... So in C++, like C, we had malloc, C++ has new. If you're writing C++ and you use new to allocate memory in 2021, you're probably doing something wrong. Generally, we try to avoid allocating dynamic allocation as much as we can. If we do have to allocate dynamically, we try to manage that allocation with some standard container, like a unordered set here. Unordered set is doing allocation internally and not exposing that to us. We could, if we wanted to, supply our own allocator and do a bunch of ridiculous stuff, but for like 99.99% of our use cases, then this is just going to handle all the memory management for us. If we do have to do our own memory management now, we would not use new and delete, because as much as people say like, oh, simply remember to call delete, like that doesn't work. So in C++ 11, it introduced smart pointers, which are essentially help you do memory management. So unique pointer is the main one you would use. You would create a unique pointer, and when that unique pointer goes out of scope, it calls delete automatically, so you don't need to remember to do it.
Awesome, thank you. Okay, let's tackle a couple of questions from the chat, and then we'll try and squeeze in one more of the Exercism ones. But let's see. Oh, Moz. Hey, Moz. Oh, there's an interesting question. Hi, everyone. I thought after Go there would be no need for C or C++. Oh, come on, Moz. No, we're actually seeing a good uptick of C++ in the cloud native community. I think primarily driven by Envoy. I'm not sure if you're familiar with the project, but it's a network proxy. And the reason I think Envoy and other projects are now starting to use C++ is for a lot of performance reasons over Go. So no, Moz, I don't think Go means we don't need it. I think there are definitely a lot of use cases out there. I don't know if you want to add anything else to that or just leave it. But
yeah, definitely. Like I think what C++ gives you is full control over the layout of your data, and in an era where like cache performance is like one of the most important areas of optimizing your program, then having the ability to do that is super important. So like thinking about how your data is laid out such that it makes the most of the cache, such that you don't have like multiple threads contending over that, can just give you incredible performance boosts. I remember once, like this was for a GPU, but adding a single no-op into a loop improved performance by 10 times because it made much better use of the instruction cache. Things like that, which you just cannot do in so many other languages that don't give you that much low-level control over how you lay out your data and how it's used and cleaned up.
Yeah. Plus, a lot of cloud native projects that even are written in Go are using CGO a lot of the time to bring in some of this other stuff too. So definitely very popular. Okay, Ben Women is asking, does C++ have an official or unofficial documentation or reference site?
Yeah, basically CPP reference is the de facto standard, is the one which most people will go to.
All right, Carlos suggesting that InfiniDash is written in C++. I've heard rumors otherwise, but we'll see. Russell is asking, are there any sites to find out Idiomatic C++?
Good question. I think there's one called CPP patterns, or did it change its name? I'm just looking it up. Yeah,
Okay,
CPP patterns. Second one, yeah.
there you go.
This is a decent one. It tells you what version of the language it allows, things like that. Doesn't look like it's been updated for C++20, but yeah, things like this. Going to Stack Overflow, like the usual kind of places you would look. There's also the hash include C++ Discord, which is a Discord community for C++ focused on making like a welcoming, inclusive environment. That's always a great place to go and say like, hey, I've got this code. Is there a better way to do this? There's always people there willing to help out.
Why don't we flip that question a little bit then? You know, you're quite involved in the C++ community. So like what are the bigger conferences that maybe people can check out some of the talks that are coming out?
Sure, like the biggest one is CPPCon. I just so happen to have this like right here. Um, yeah, CPPCon is usually in September. It's going to be October this year. It usually has like six, seven, eight tracks. Runs for about a week. It's a pretty big conference. I think I gave four talks there last
Oh
year.
wow.
One year I gave five talks and like helped run a panel and things like that. I would not recommend doing that. It was exhausting.
Sounds like a stressful week.
Yeah. Yeah, but CBBCon, C++ now is probably the best one for like expert level content. And then the smaller ones like C++ on C, CPPP, which is the C++ Paris, the Madrid C++ Spain one. There's a bunch of smaller conferences as well. ACCU as well has a bunch of really great C++ content.
Right. Definitely no shortage then of C++ content
Yeah,
for
yeah,
people.
yeah. And the conferences are only growing as well. Like there's new, obviously not right now, but previously there were like new ones popping up pretty much every year.
Awesome. Okay. Let's use the next kind of 15 minutes to maybe just tackle one more of these. And we won't go through all the test cases, but maybe if we can pick something that shows off a little bit more of the language. Is there any features you think would be nice to show, and we can try and find an exercise that uses them?
Talking about type inference would be good, but I feel like we can build that in pretty much anywhere. Um,
Let's see. What about
Nothing involving randomness, so that I don't have to explain randomness in C++.
uh, it says pattern recognition here. Is that
All
pattern
right, yeah,
matching?
yeah. We can go for, there is not pattern matching, but
No.
at least we can talk about that um, and what might be coming in the language.
Yeah, okay. Well, let's see what we can kind of make out of it. Even if we go a little bit off script, that's all right. So let me clone this one. Jump over here. So what is it asking for? It wants us to generate the lyrics of the song I Know an Old Lady Who Swallowed a Fly. Not a song I'm familiar with, but it's a cumulative song of unknown origin. Yeah, I have no idea what this is asking.
Yeah. So I think the song is usually like you have a line, and then in the next verse you repeat that line and then add a line, and then in the verse after that you repeat the first two and then add another one. So it's like building up the song.
Okay, let's see if they give us any code to start with, and then we'll make a decision.
Yeah.
So we got our test case here. We're expecting a string. All right, okay. So we're calling a verse function, and we're giving it how many verses we want out of it, or new lines added to it, I guess.
Yeah.
And let's see what we have. Oh, we get nothing. So it's if maybe we could just make it up. Like it doesn't matter if the test passed, but maybe we can talk about pattern recognition, and maybe we can talk about type inference as we go. Are you comfortable kind of just making this up?
Yeah, 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 we
Yeah.
can just make something up. Um,
Okay.
so the um, yeah, type inference. Why don't we just make a function which doesn't return anything. Just we've got something to play with. Yeah, void means I'm a function which doesn't return anything. Void is like a special type in C++. It's not quite a unit type if you're familiar with the concept of a unit type, but it's the closest that C++ has, basically. So type inference in C++, like previously we've been declaring variables by writing their type and then a name and then an initializer. You can also write auto instead of a type. So if we write auto here, and then name, equals, so this will, based on the type of the initializer, will deduce a type for that variable. So this uses the same rules as templates do, which is kind of nice in the way that it's like that this came in C++ 11, kind of reused a lot of the existing rules in the language. But basically, when you're using more complex C++, you end up with really, really, really long types. It might be like a vector of the iterator types for a vector of integers, and you don't want to write that type yourself. So we now allow you to write auto in there, and it will work out the type from the initializer. It's not like Rust in that it will like look how you use the variable downwards in the function. Like in Rust, you can say, I have this is a vec, and later on you like assign an int into it, and then it like looks forward and says, oh, later on you use an int, so this must be a vector of integers. In C++, it has to be based on the type of the initializer. But it cleans up so much code, and you can use this in range space for loops as well. Like earlier, we wrote char C, which was the type which we were iterating over. But you could just write auto there, and it will work it out for you.
So you're saying we could have done auto C name.
Exactly. Yep.
And then whatever C. Okay.
Yep.
It seems to be complaining about my explicit type is missing and assumed.
Yeah.
But when I hover over, is that just my editor again? Maybe.
Yeah, I think it's just your editor. The compiler would be happy with that.
Okay.
Maybe something else we can talk about is references.
Yeah.
So if we write two functions, and make that one take a std string. Yeah. And then write another function called, whatever, another one, some other, Okay, and make that one take a std string ref, so ampersand.
Oh, ampersand. On the variable name? Or before the standard string?
It's after standard string. It doesn't matter which side of the space you put it on.
Right, okay.
So these are two different functions. Another takes the string by value, which means that the inside another hello is some completely new string, which is completely separate from any of the context outside the function. So if we pass, say, our name from inside our hello function, the David thing, into another, then nothing can ever happen to that name. It will be the copy inside of another is something completely separate. The version of some other, however, has the ampersand after the std string. This will actually not compile. I'll get to that in a second. But when we put an ampersand after type, that means that it's a reference to that type. It's not a copy. It's like an alias for something else. So in C++, references are mutable by default. So if you pass some string into some other, then some other could, for example, change the first character of the name, or it could append some additional data onto it. This is how you can like mutate things while passing them around functions. And then if you wanted to make it a reference, but you cannot change it, then you would do const std string ref in the declaration of some other.
Okay. Mind if I ask a few questions?
Yeah, go ahead.
Okay, so if I hover over David here, it's kind of the type inference is maybe suggesting that this is a const char 6, but it doesn't seem to mind me passing that in as a standard string. Is there some type juggling happening here?
Yeah, so C++ has implicit conversions, which is basically in some cases you can pass, you can initialize some object with an object of a different type. And as long as there is some conversion function which can convert between the two implicitly, then it will just work and it will do some magic to convert it. And there's a few different ways that you can specify those conversions. So converting a string literal to a std string is one of those cases where there is an implicit conversion function which will take the contents of the string literal and copy them internally into a std string, and that will potentially allocate some memory dynamically, which will then be freed when the std string is destroyed.
Right, okay. So if I were to implement my own type in C++ and I wanted to be able to convert it to a string, that would just be implementing a function on
exactly.
Right, okay.
Yeah, and implicit conversions are a little bit contentious because in some places like this, they're super useful. Like, of course, you want to be able to convert a string literal into a std string. Like, that's something which is really useful to do. In some other places, like, they seem like they might be ergonomic, they might make things easier, but you can run into issues where you get like implicit conversions where you maybe didn't want them, and it can cause some additional errors which are really, really difficult to see because like you said, you see that you can pass this thing of a different type to another function and it just works. Some magic happens, but it's not obvious that there's a conversion happening here. You have to know that these two types are different and that there's some way to convert between them to know that there's a conversion happening. It's not clear from looking at the code.
Awesome. All right, I'll throw one more. We don't need the code up anymore, I don't think, unless we want to jump back. But I'll throw one more question at you, just because, again, I have curiosity. Like, we've been now writing C++ for a little over an hour, and we haven't typed a single class. Is that normal in modern C++, that you use maybe just functions within namespaces, or does it just, again, come down to the domain, maybe, that we're actually building something out?
Yeah, it definitely comes down to the domain. A lot of the power of C++ comes from the ability to create your own, to work at the level of your domain without having to pay runtime cost in order to do that. So what that means is creating your own types, which express, your business logic or whatever you want to call it. Being able to write templates which abstract common behaviors of your types, being able to create code which can sometimes read like the operations you want to do, but will like compile to a bunch more code under the hood. But you don't have to like handle that, but it will happen in a way which is which still gives you the performance that you need. So the common term that's used is zero overhead abstractions, which is another like slightly contentious term in the community. But basically, it means that being able to write code at a high level of abstraction without paying undue performance cost.
Awesome. Well, thank you very much for joining me today. It's been really good fun learning C++. I'm really glad that we kind of, understand or dug into the tooling a little bit. I had no idea about CMake. Really cool to see the way that tests were structured, and then just a few nice implementation details of just to acquaint myself with the language. But I feel like I understand things a lot better now. And you've been into quite a fair amount of detail in some of those features as well. So I just want to say thank you very much, because it was really good fun.
Yeah, thanks for having me.
All right. Well, you have a wonderful day. Thank you again. Thank you to our audience for watching. Do you have any last words before I say goodbye?
No, I think if you're interested in like learning modern C++, I would have a look at um, Kate Gregory's Pluralsight courses. They are really good and teach like modern C++ for beginners in a way which I really like. There's a bunch of really good books. Like Stroustrup's A Tour of C++ is now updated for C++ 17, I think. I can't remember how much C++ 20 is in there. But also, if you've done C++ before and you are interested in like how C++ 20 will change things, I'm really interested in like making good resources for this because we're still in the education phase of this. Like C++ 20 is kind of new and it comes with a lot of really new like big features which can really change the way that we write C++. Like we talked about ranges and being able to compose these in a way which you might be familiar with from other languages like chaining iterators in Rust or whatever. So yeah, keep your eye out for resources on that, and let me know if there's anything that you're particularly interested in, because yeah, I want to like make good stuff on this.
All right. Well, I will make sure I include a link to your YouTube channel and to that Pluralsight course and all of those other C++ reference websites that we mentioned throughout the session. They'll all be in the description. And thank you again. Have a great day, Si. It was a
Yeah,
pleasure.
thanks. Yeah.
Thanks.